My name is Godwin Amadi, and for today's webinar, we are going to look into the best practices on how to architecture. We are going to be learning introduction into code-based architecture, where we are going to learn the principle of code-based architecture and how different architectural patterns impact scalability, maintainability, and performance of applications. We are also going to learn the introduction to key and layered architecture patterns, where we learn common architectural patterns used in backend development, such as the monolithic and microservice architecture, and the benefits of this architecture, such as for the start, backend architecture is the backbone of any and every enterprise web application. It handles and manages the logic, data, and communication between the client and the server. It helps you to organize and structure the code and data that runs on the server side of the web application. By so doing, it demonstrates how the application handles requests and response from the clients, which can be from the web or the mobile. How it interacts with the database and other external services, and how it handles security, performance, and scalability. For every solution that you're building or intend building, or most times as developers or people in the technology world, most times we may get carried away with wanting to have so much emphasis on how, but for the start, what our priority should be the structure and how we're going to the structure of that particular solution, and how we're going to make sure that we are starting up that solution in such a way that in the future, when we intend to scale it or when we are onboarding new developers on that particular solution, there won't be any form of issues, and as well as when deployments are going through. Once the backend architecture or the code base is structured properly, deployment, there won't be issue in deployments and management of that particular. It's very paramount that we place more emphasis in how our solution should be rather than just the code base. So this is a graphical representation of this particular. At the center of the backend architecture is the server. So in the server, this is where our application runs, and the server is meant to run 24/7. It's not meant to have any downtime except in situations whereby we are having scheduled maintenance or in negative circumstances where there is an attack from unknown users. So for the server now, they are going to have applications running on this server. Most times they definitely have to communicate, store the data that they're getting from the clients, which can be coming from the desktop, the laptop, a workstation, your phone devices. You have to store those data into a database. So this depicts the backend architecture from the server to the database and every other thing that goes into it. So along this particular webinar, we're going to touch very important aspects that make up the server and database, and the architecture that actually works with it, that make sure that once you build up a solution using a very proper architecture, the maintenance will be very, very efficient. The main elements of the backend architecture, you have the server. This is a machine or computer that hosts the application and listens for incoming requests from clients. It can be physical, a cloud server, or a remote server. It's meant to be up 24/7, as I earlier said, with little or no downtime, except for reasons that are within or outside your control. The server now, as I said, is where your application is meant to be running and is meant to be up. And at the same time, why most times we call it a server? Your system to your PC can be a server, but why we don't actually use our PCs for servers? Because of amongst the elements of the backend architecture, we have the app. So this app is the application of choice, the application, the solution you're building. And this application can be built with any programming language of your choice, either C#, Node.js, PHP, whatever programming language of your choice that you decide. That's the application. They also have a database. So this is where you store your data, and it can be relational or non-relational. Depends on the nature of the data that you're collecting from your users. I would say these are the core elements of the backend architecture, and they are more like the building block to the bigger picture of how the backend architecture is structured. So properly. So we'll start off with the monolithic architecture. So the monolithic architecture, I'll read this off so that you can have a bit of insight into what the monolithic architecture is. So the monolithic architecture, this is where you have a single app that handles all the aspects of the application, such as authentication, payments, business logic, data access, whatever you have, whatever service or feature that you intend to build into your solution. It's simple to develop and deploy, but it can be difficult to scale and maintain as the application grows in complexity. It's a traditional method of software development. Although monolithic architecture has its own disadvantages, it's still the best if you're building a small application and needs it to be as straightforward as possible. So for the monolithic architecture is the traditional way of building solutions, where you have a single app, you have a single database, you have a single server. and they all communicate together, where your application is dropped in the server that is running, and the solution or the app is communicating to a particular DB. It's very, very straightforward. And whatever services, whatever features that you intend your application to work with, let's say you have a little, let's say you have a mini store, and in that your store, you're going to receive stocks, you're going to deliver stocks, you're going to do a little bit of finance related activities like accounting, you're going to pay your suppliers, whatever you have it. So those features now, they're all going to be built into your app. So as you're developing your application, all those features, you build them into the application without isolating those features. You'll all be in that particular application as features. Then those features will be stored on a particular database. So that's the traditional way of building applications, and it's very straightforward. And most times, as let's say a startup, if for instance a startup and you're trying to also manage your costs, trying to hit the market as soon as possible, most times it's advisable to go the monolithic architecture path, whereby you just spin up your developers. Most times they are not usually in large numbers. Maybe say you have a team of 2 or 3 or 5, and they are very conversant with a particular language. Let's say they're very conversant with Node.js, they are very conversant with C#, whatever language of choice. Maybe those developers are very conversant with, and you have a deadline to ship your solution to the market. With the monolithic architecture, you spin up the solution, your developers get to work, they begin to ship, and before you know, within a short time, your solution in the market, which is quite different with the next architectural pattern which we are going to surface in this webinar. This is how the monolithic architecture looks, whereby we have, looking at the center of this particular graphics, where we have the storefront UI, the accounting services, the inventory services, the inventory service, the shipping service. Let's assume that these features, let's assume that this accounting service, these are all features, and let's say this, what you're seeing here is your solution, which has all these features in it. So once you spin up your application, you build all these features into that particular application without isolating it, and to have a single database. And once users using from their browser hits this particular website or this particular solution, they have access to all these solutions straight up without any difficulty. So this is what it looks like. So when do you use monolithic architecture? The application is relatively simple and has limited functional complements. The development team is small and familiar with the entire code base. There is need for fast development cycles and quick time to market, as I earlier said. The application has limited scalability requirements and can run on a single server. So, so this particular type of architecture in building solutions, you're very sure that going forward in the future, this application won't go beyond your control. You're very sure that this application, the features or the services you're going to be rendering from this particular solution or application is quite limited, and with that, you can just go along with this particular architecture in building your solution. And at the same time, you're also very sure that the traffic, most times once you're considering building a solution and choosing a particular architectural pattern, you also need to consider the traffic that particular solution is going to get. If the traffic is quite limited, let's say, in most, I'll give an instance with the bank softwares and the asset management softwares, because I'm in the industry. So most bank softwares, usually they have heavy traffic because everybody is actually interfacing with the bank. And due to that, going the monolithic architecture is not usually an advisable architecture to build solutions that they'll be presenting to their clients or their clients will be interfacing with, because there'll be so much traffic. And most when there's so much traffic, they need to scale the server. They need to scale the server, either horizontally or vertically, either by expanding the resources in which the server is running on, or running additional servers that point to a particular, that still points to the address of their solution. But in contrast to most assets or pension solutions, most pension solutions or asset management solutions, most times they don't usually have so much traffic. Because in Nigeria, or let's say, let me give an instance in Nigeria. In Nigeria, there's really no much of an investment culture. We are more consumer based due to per capita influence. And most times asset and pension, let me just emphasize on asset management tab. Most asset management investment tab, most times people that actually interface with it are people in their, let's say, late 40s, late 50s, late 60s. You hardly see youths in their 20s or early 30s or even late 30s interfacing with it. So most times the traffic going into those solutions are very, very limited. So most times when they spin up solutions and they can just go along with a single server, a single database, they can go along the monolithic architecture, being very sure that there won't be so much need in the future to scale the servers or the resources in which these solutions are running on. So we'll now look at when not to use the monolithic architecture. The application is expected to grow significantly over time, and we need to scale horizontally to accommodate more traffic. That is adding more servers. The application has complex or diverse functional requirements, and we need to be divided into smaller, more manageable components. The application requires high level of availability and must minimize downtime during deployments and updates. So when you're also considering to build a solution and you're considering whether to go the monolithic architectural route, you're going to also consider this point listed. Is this solution meant to be up and running 24/7? Is it meant to have very limited downtime? If that's the nature of that solution, it's not meant to go the monolithic route. If at the same time you're very sure that this particular solution will have complex business functionality, let's do the instance of the banks as well, because we are very, very familiar with the banking softwares. In the banking software, beyond authentication, which is login and logout, beyond you making withdrawals and payments, there are so much features in the bank apps. The bank apps now, they enable you to do investments, they enable you to pay your utility bills. There's almost like they enable you, maybe those that do betting platforms and some other platforms, you can actually use the bank account to top up your account in different platforms. And other services. So in that instance, the banking software is very complex. So going the monolithic route is not actually advisable because that solution is quite complex, and the monolithic architecture won't really attend to the needs of that solution. So now another type of architectural pattern we are going to look at is the microservice architecture. This is more like the non-traditional way of building solutions. So here you break down your app into smaller and independent services that handles a particular functionality in the application, such as payments, notification, authentication, and whatever you tend to have in that particular solution. And they communicate using an API, that is application programming interface. It is more scalable and flexible than the monolithic architecture, but it can be challenging to coordinate and develop. So the microservice architecture now is a situation whereby the solution is going to have so much, just like the bank solution, the bank software that I gave an instance with is dealing with so much features, so much services, because I'll be using features and services interchangeably because they are mostly the same. Most of the terms are actually used in similar way in the programming world. So they have so much services or features, and judging based on that, due to the complexity, using the microservice architecture is the best way, because these services now, these features are going to be built independently from each other, and due to that, it creates this ease and flexibility in coordinating that particular solution. So we'll now look at in the microservice architecture, there are also patterns, more like design patterns or types of microservice that you can actually key into when building, because the microservice architecture is quite big and wide, and most times you need to really decide on what type of microservice architecture you want to go with. Okay, so that when you're beginning to spin up your microservices, you now know how to structure those services that will be running independently. So for the start, for this particular webinar, we're going to look at two major or two common types of microservice design pattern: the API gateway and database microservice pattern. So starting with the API gateway pattern of the microservice, the API gateway serves as a single entry point for all clients' requests. It routes requests to the appropriate microservice and subsequently aggregates the response. It centrally manages concerns such as authentication, monitoring, and rate limiting. Furthermore, it provides a unified API that is easier to consume by the client, shielding them from the complexity of the microservice architecture. It comes with its own unique challenges. That is a single point of failure unless when designed properly and highly available. So, I'll use the graphical representation of these patterns of design pattern of microservice to give better clarity to how they function. So looking at what I have on my screen, this is an API gateway microservice architectural design, where we have the API gateway here, which is the point of entry. And after the API gateway, you can see these services. These services, as I said, I'm using services and features interchangeably. So these services or features now, these are services and features in which the solution that is built into the solution. Let's say an e-commerce app that has a catalog, that has a shopping cart, that has a discount. It runs discounts on this. You can run discounts at certain times of the year. It also has an ordering feature as well. So all these are features that are running on a particular solution, that a particular e-commerce solution, let's say Jumia or Konga. And this particular solution, the clients or the world is interfacing with it. And using this particular microservice architecture, you you actually build these features or services independently. But the uniqueness of this particular design is that once you build these solutions independently, you connect them using the message broker. They're able to communicate with themselves using the message broker. But the thing is that this particular microservice design has a single point of entry to have access to all these features or services. So the API gateway is the point of entry. So what you do as a developer, all these services, if they are within a particular server or different server, depending, but I'll use the instance of they are running on a particular server. So that particular server now that is housing all these solutions that are built all these services that are built independently, in which our solution will utilize. They are connected together and giving a single point of entry using the API gateway. So this single point of entry, and that's the point of entry whereby the authentication is done to have access to these services. So when the front end or the front end guys consume this particular architectural pattern, what they just have to do is to key into the API gateway. They connect the API gateway. For this API gateway now, we expose an API to the front end or to the front end guys, which they consume. And using that API gateway, once they execute a particular API, let's say they want to get catalogs, the catalogs that have been profiled in the e-commerce application, they just execute that particular API. Once the execution is done, it hits the API gateway, now redirects it to the particular service in which that API is pointing to. So most times there are unique identifiers for these different services. So once the call is made, the API gateway just routes it. So let us see this API gateway as a routing, a central routing system, where when calls are made, it routes it to the service that the front end guys or the solution wants. And that's how this particular microservice architecture is utilized. And most times, it can actually use a central database, or each service will have its independent database. So let's go further. We also have the database per service pattern. So this is another type of microservice architecture pattern. So in a monolithic application, all modules typically share a single database. While this approach might seem convenient, it leads to a tight conflict between the modules, making it hard to scale and maintain the application. The database per service pattern provides an elegant solution to this problem. In this pattern, each microservice owns its database, ensuring loose coupling and high cohesion. This allows each microservice to use database type that is best suited to its needs. However, implementing database per service pattern can be challenging. It involves dealing with distributed data, managing issues like ensuring data consistency across services. So I'll just give a brief elaboration on this type of microservice architecture pattern. So the thing is that this type of microservice pattern is whereby it's mandatory for each service or each feature to have its own database. You won't build a microservice whereby there's a central database for each service or each feature keeps its data to its own database. So by so doing, you've decoupled, because the whole essence of microservice is to decouple how the services or features are built, making them very independent. So that's the grace or the benefit of the database microservice pattern. It decouples the services or features to manage itself and transfer data to its independent database. So what the solution will do when it's consuming this type of microservice architecture pattern is just to get the API that these services are running on and key into it and do inter-service kind of communication, whereby it executes APIs that actually target each of these services. So the benefit is scalability, flexibility, resilience, and fast deployment. So I think in all of this, the major benefit in microservice architecture is the flexibility of it and how it enables fast deployment. I think that's one of the key benefits of microservice architecture, the fast deployment nature. Because in a situation where you have a microservice solution, you can actually build this. You can actually build features and fix bugs independent of each of the services, and make deployment as well, so that when any of the services is having deployment, it doesn't really affect the other services that work together in that microservice architecture. So look at the drawbacks. We have complexity, increased cost, the need for automated deployment, network latency, and error handling. So the more complex the architectural pattern is, the increased cost of it. So we'll now look at So in all of this, I think we have looked at how to structure our solution. But now let's look at how to structure our code base, because beyond how to structure the solution, it's also important you structure the code base such a way that when you have developers on board, or when you go for vacations and come back, you can actually know how to go back into your code base and build features without getting lost. So that's what the layer architecture actually depicts in the backend architecture. It gives you a policy of structure. So I'll just touch on a few structures. So when you're structuring your code base, you need to structure code base around these few layers in which I'm going to touch on. Database layer, the DTO layer, which is the layer in which you determine the kind of contract or what you'll be exposing to your clients. So let me just touch on this DTO. So DTO transfer, there is a contract between the application and the UI. An expected object of value or response that returning an API is executed. So this DTO layer now is a layer whereby you determine the kind of response that a client gets when they execute a particular action or a particular API. Is determined, so that when your client developers are consuming, they can actually mock their UI, knowing fully well that this is the expected result and this is the expected request. That's what the DTO layer is all about. So you also have the service layer. So this is where you build your business logic. So all the business logic you're going to build in the service layer, and this service layer is between the database and the controllers. So the controllers, this is the layer that receives all requests, passes it to the respective services that will process it, and afterward returns the response that is received from the service. This should not contain any logic or data manipulation. So the controllers is the layer that stands between your user interface, which is the website, and the services or the database. Because once you go into a particular website, and let's say you want to log in or you want to make withdrawal, once you execute that withdrawal now has a URL. You can have let's say GTB/withdraw or GTB/Godwin/withdraw. Once they hit that particular URL, it's the controller that receives it. So what the controller does, once they receive that particular URL, it now pushes that request to the services, and the services now consume that particular business request and returns the response. So once the service returns the response, the controller now takes that response and returns it back to the client. So basically, the controllers are more like the interface between the UI and the backend, the UI and the backend in this particular instance. And this just gives a graphical representation of the communication that happens between the controllers, the services, and the database access layer. As you can see, the controllers is at the top of the food chain. The services in between, and we now have the database access in which the services have access to, and once they have access to it, they now return whatever response they have to the controllers. So I think at this junction, we have to, I think I've been talking for some time now, and you have to take some questions before we round up.
Can you please talk about cookies we accept on websites? Okay, Godwin, you have a question.
Okay, yeah. So cookies are more like cookies come in different instances. There are cookies that allow you to have access to a solution, and there are also cookies that help identify users in a particular platform. But the cookies you're talking about is the cookies that are used to identify users that access a particular platform and how they actually interact with that platform, so that when next they gain access to that particular platform, the platform knows the user's choice, what the user expects from that particular platform. So for instance, when you access let's say an airline platform, let's say Airpeace, and you accept cookies in that particular platform, their website. So, and maybe you browse for air tickets going from Lagos to Abuja on Tuesday, or you browse for air tickets going from, let's say, Lagos to Owerri. So they'll cache that your particular interaction. So subsequently, when you come into that particular platform, the airline platform, they will give you more information about those areas that you actually interacted with, and they'll give you maybe traveling discounts, traveling time for those locations. So that's what cookies do. It saves information about how a user interacts with a platform or a website.
All right, thank you, Bashirat. Thank you, so Godwin, for answering that question. So yeah, back to the one that I asked. Oh, okay, we have another question. Two more questions, and still in line with cookies. What's the safety like? And then someone else is asking, I read somewhere that they gain access to our personal details through cookies. Is that true? So Godwin, you have two questions on the same topic.
Okay, they won't entirely gain, because every cookie that you accept, it actually has a contract attached to it. Last most time they tell you, okay, read this and accept. But depending on the nature of the platform, if it's a platform that doesn't really require a lot of authentication, maybe it's not a bank app or it's not a financial organization platform, whatever cookies you're going to accept, the kind of information that will save about you won't really be so private, because in such a platform you can't go and be giving out your bank details or some kind of private information. But at the same time, they can actually save your information. But the thing is that how they utilize such information is also under privacy laws. They'll take your information, but they won't actually depend on the information they get from you, and depend on the privacy laws that that particular the kind of privacy law that particular solution is. Let's say if a solution is running in Nigeria, the kind of privacy laws that is guiding that particular solution is quite different from the privacy laws that is guiding that same solution if it is operating in, let's say, in America. So that's kind of limits how to use your information when maybe you key it in and accept when you accept their cookies. I don't know if that answers it.